you're talking about it.
Okay.
Uh, yeah, it's it's gonna be nice. Like for me, it's more of a technical motivation that we can share. Because we have, when we create these hybrids with VS Code, it's really difficult to understand how everything works. But if we now, like in V1, we have this monster of a hybrid, uh, but now we have this clean into this package that we use between our editor and VS
Hmm.
Code, and that means that we could have this separation where if we want to do something that's related to VS Code, we can actually implement it as a VS Code extension, and that has like a clear documented approach that everyone can like understand. Um, and we don't have like these hacky things. I'm really curious about how it works under the hood, but that would be
Yeah.
ideal, I think, at least from a technical perspective.
Yeah,
Do you
I
know
I
why the
think
oh, oh sorry, go on.
yeah, I think the EV's ultimately goal is to implement the GitHub VS Code extension and run inside the server, and this would be a game changer for our editor.
Yeah.
Like the user can opt in to extend by their own on our editor. So we kind of open our editor for the world to make their inside introduce their preference inside of this new environment.
Yeah.
In this is really exciting. This is a really exciting challenge.
Yeah. Yeah,
Yeah.
exactly. And it's what's also nice is that we're doing this from the same perspective. It's like it's our editor primarily, and then we put VS Code in there. It's not VS Code primarily, and then we put our editor in there.
Yeah,
Um, like I'm not saying that would be wrong. It's just a different perspective. That's more similar to how everyone else does it. So we have more opportunities to differentiate ourselves and create new experiences. So,
There's a
anyways,
bit of a
oh, sorry.
polish needed on some of these tabs, I think. But that's looks good.
Mm-hmm. Yeah, if anyone's joining, we're talking about some adjustments to VS Code integration in our editor. That's coming soon. But now we have Alex joining us. I have to be careful so I don't like lean too much over Danilo. We're a bit cramped in the corner.
no, I understand.
um, but yeah, I thought we could show you a demo, Alex, of what we built, like from a user experience perspective. And then we're going to let you like free roam in the code and kind of just listen to your first impressions and questions you have. And then we'll just see where that goes. And then I probably get too excited and I start talking about how some things work and so on. But yeah, we'll see how it goes. So um, for this exploration, we created a new page called Impact, which is basically like re-implementing parts of the editor. So we have like the GitHub URL part here. And if I refresh now, it starts loading, it connects to picture and connects, and then it's opened. And then if I click this Git sidebar thing here, it shows the Git status and it loads up the suggested commit message. And then if I move back, it kind of keeps that around, that message. Do you have access to the branch, Danilo? Could you change a file?
Yeah,
I can do it here if you don't have it there.
I don't have it now, but I can
Yeah,
open.
it's test sandbox chicken soup. And this is the fun thing, Alex. Like when we first connected to Pitcher on stream and then Danilo started changing on actual stream, we actually see the updates coming in here, which is really cool. And it's like it's crazy. Like we built these abstractions through the process of implementing the editor, like the CodeSandbox API and Picture Client. And now this is the first time we kind of had those packages from the get-go and then implemented it. Yeah, so it changed it and it updated as suggested commit.
That's a diff, right? Or is it it's a new diff that Git detected.
Yeah, so currently we're just listening to updates to the Git status. Cool. Did you open the branch?
Yeah, I have it here.
I wonder if follow mode is working. We have to review follow mode after the VS Code stuff is
we have to. I think Firefox still has some issues with it. Let me see if it works. Doesn't work in Chrome either. Okay, we have to review follow mode anyway. That's another topic.
Yeah. Have you a file open now? Sorry, I should probably tell you where it is. So in the source folder, there's an impact exploration folder. That's what we're looking at.
Yeah. Oh, I have it open. I'm here.
Oh, there you are. Oh, you're that one. Okay.
Oh, yeah. Let me close my other tab.
Oh, yeah.
Right. Got it. Does it work when I navigate to?
Yes.
Oh, it works. Okay.
Nice.
Says
that's the engineering team at CodeSandbox.
It works. Nice.
Oh, that was a surprise.
Job
done. Cool. Yeah. So basically, just try to look around and see if you have any questions to what you're seeing, and we'll certainly be here to help you out understanding what the hell we've done.
Sure. So this is basically the page. This is the root of that page, I assume, the index file. And I guess one question is, does this use anything from outside, or is it just like kind of isolated? Everything is within this folder, right?
Yes, everything's within the folder.
Okay. Cool. So we have the error boundary. I know you've been working with the Suspense API. I have literally no experience touching that, so this will be fun.
Yeah.
I don't know what it's supposed to do. Like I guess that makes sense. Session is the component that renders inside Suspense. Right, and then session actually adds its own provider and then renders branch. Then branch is inside session. And renders its own provider as well, right? Am I going the right path here? Like,
oh, there's no right path there. There is only your path, Alex.
Right. Cool. So let me see how. All right. So each component, like on first sight, it's interesting that kind of, or it's just the path I went through. It was interesting that each kind of, I don't know, let's call it the main component. How should I call it? Like session was using like the global context and then was wrapping in a provider the child component, that the child component was using that provider and is then rendering its own provider, so it uses the context from the session.
Exactly.
First thing which makes, like, one thing that is kind of, I guess the one obvious question for me is, why is the provider needed if, or maybe that's not, maybe it's just the sim, because it's a simple example, but why is the provider needed if the communication is kind of like parent child? It doesn't necessarily bypass the hierarchy, or doesn't have to, like, doesn't provide somewhere top level and then some child
Oh
on
yeah.
a very
Yeah,
third level child uses that, right?
exactly.
I guess
Yeah,
that would be that would be the end goal, but
yeah.
in this case, it just feels like it's overkill, right?
Exactly, and it is overkill, and that's the problem with um discussing with people why you need these kinds of solutions, because it's not obvious in simple examples. It's
Yeah, of
exactly what
course.
you say. If this was an actual editor, it will be way more apparent.
Yeah, yeah,
But
because you have all these like in between. I guess you can call, if we call these, let's use the old style jargon. If we call these like connected components, right, that reach into the state,
mhm,
you would most likely have all sorts of like layout components and visual components that go in between, right? And
mhm,
then you have your other connected components somewhere like 4 levels deep into the tree,
yeah,
and then you
exactly.
definitely don't want to pass tons of props between them.
Yeah, and another aspect of this nesting is related to when they're mounted. So, like if you think about the global context that we use, that one is mounted once and never disappears. It doesn't matter what
Yeah,
page you go to, what feature, it doesn't matter. It will always be there. But then you have the
exactly.
session context that we have bound to the authentication state of the user. So if the authentication state changes, it will remount the whole session, which means all the state from the previous session will be completely gone because it's nested within the session. And the same for the branch.
Mhm.
Like the state we put into the branch context, when we change the branch, all the state of related to the previous branch will also be automatically disposed because it's in that
Yeah,
context. So it's about
Yeah,
lifetime of state. Yeah.
but the session state is still valid when you change a branch, so it makes sense.
Yeah. So as an example there, that's why the session context has branches and branches, for example, because you want to be
yeah,
able to like fetch a branch and even cache the branch even when you're changing to a different branch. So we keep that in the session context because we want it to live beyond multiple branches. um,
right. And then let me see how one of the contexts looks like. Oh, it just combines. I guess it's a similar with the combine multiple slices of state, let's call them. Uh, we have feature and branches. Again, this is session context. One thing that okay, this is gonna sound dumb, but if
no.
branches is part of session context, what's inside branch context?
Yeah, exactly. Yeah, but it's such a good point. And this is, it's so difficult to name things and how to
Yeah.
conceptualize things. Like, even here, just talking about context, like in the current implementation, we create a context per feature, which makes sense. Like you have a whatever AI feature, and then you create a context for that.
Hmm.
But here we're talking about context more about like the lifetime of state and what functionality is needed within that
Right.
context. It's not about a feature, it's about availability of state and management of state.
Right. So basically, the session provider will provide uh, these
Yeah.
the
Whatever
state
state and management
as
of that
long
state.
as the session provider is mounted,
Yeah, exactly.
and then the branch provider, which is in wait, I got lost here. And then the branch component actually, which yeah, this is the tricky part. Ah, can I can I bash code that is in index files?
Yeah.
I After working with CodeSandbox client, it's like, why? Why everything has to be in an index file?
Yeah.
Yeah. Now here it's much clearer, but like
Oh, that's
I have
actually an
I have a
interesting point. Because sorry to interrupt, but one of the
no.
reflections here has been like when we use these folders to also represent context. Like you have this index file where you have where you partially want to like mount the actual context. Like you want to fetch some
Mhm.
data for the context you're about to initialize. You initialize the context and then you render out the actual content that you
Yeah.
want to show. And it would be nice if the index file could represent, okay, the initialization for
Yeah.
this. And then you would still use, so for example, for the branch folder, you would still have a branch file, which is the actual
Yeah,
branch
exactly.
content. Yeah.
Yeah, that's what I wanted to say. It's almost like this is like, okay, this is the provider, and then this is like, let's
Mm.
call it, I don't know, branch UI, or maybe not the right name,
Yeah. Yeah.
but you could argue that, okay, this folder exports, like the index file is kind of like the contract that the
Yeah.
branch exports, right?
Exactly.
But then when you look inside and you want to look at the 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 UI tree then that the branch represents, okay, then that's a separate component that just looks into the provided data and then renders according to logic and does, you know,
Mm-hmm.
callbacks and states mutations and whatnot,
Yeah.
or dispatches or whatever it is.
Exactly.
Because that's maybe one thing that definitely you will have a hard time figuring out, okay, where is the editor. Like I have, there's this, let's call this editor, this is a pure UI component, right? I'm looking at it,
Mm-hmm.
and where is it rendered? Oh, it's rendered in one of these, like this part of JSX is maybe this is actually branch in this state, this is the branch UI in a way, because this is the
Mm-hmm.
only thing that's rendered here.
Yeah.
But maybe this would be inside of some sort of like a layout component with like some sort of header customization based on whether the, you're rendering on this path or rendering on that path.
Mm-hmm.
uh, Loading state if needed. I don't know if does the async part all get deferred to the top level suspense, or is it per component or per feature?
It depends on so the way Daniel and I discussed this is that like if we think about this entry point, which is at the contract, as you say, between this context and the UI, that's a good place to not only create a like expose the context, but also set a suspense boundary. So if anything needs to
Right,
load within this context, that's also defined there. And also if an error happens within this context, you use an error boundary there as well.
right.
So yeah,
So this pattern, this thing that is in the, is in the top level component, like the error boundary plus suspense plus the
yeah,
session. This is actually similar here. This is actually, instead of session, could be called like global UI or whatever page,
yeah,
root something, root layout, whatever it is.
yeah,
Uh, but then it deals with all the it deals with the async part, async. It deals with the async state of its child, right?
yeah. You could say that it like very often like when you go to some piece of UI, you want to like asynchronously initialize it. Like it depends on some data.
Yeah,
And what we do there is that we uh, we kind of do that right there. We get the data and we shove the initialized data into the context so that when you consume that context from the child components, it will be there. It won't be async anymore, which is kind of the challenge we've had in version 1, where all the state
right.
is like global and you have to check if it's there or not all the time. But here we use the component tree as a data fetching mechanism to initialize nested contexts, and then yeah.
A couple of weeks ago, we talked about this problem, and we end up with this term, which is like a data boundary. Once we are inside this context, we know that the data is there, so we can rely when we are using this data.
Yeah,
So we no longer need to check if the data is there.
Yeah, this is one of the frustrations with async data, that you have to constantly do the checks, right?
Yeah.
So here in the session component, I just expect that whenever I use whatever I need from the global context will be available when this renders.
Yeah.
The same way as the branch knows that anything coming from the session is there. You don't have to check if user is authenticated or
Yeah.
I mean, it depends. Maybe you
Yeah,
want
it depends on
anonymous
the
users
like
as
for
well,
us.
but
Yeah.
no, you don't have to test whether you have the data from the user, has the the current API call finished returning user data, you have the user data, or it's anonymous. Like it drops that uncertainty from the state.
Exactly.
Arguably, like you could expand this to like the workspace, right, or any other piece of data, because we've been having these issues, and this is actually a problem in the dashboard as well. uh, the uncertainty of the data, and we ended up with this pattern where not always, but in some of the cases where this is more challenging, we clearly say, oh, data is undefined, which means it hasn't arrived yet. If it has arrived, then it's not valid, then it's null. There's no null or undefined, which is just like a random like you don't pick null or undefined based on how you feel about it. You just say, oh, it's undefined, it means it's not defined yet, right? Wait for it. So arguably this would get rid of undefined states altogether.
Yeah, exactly.
If you follow this path,
yeah,
right, you expect inside the session the user to either be null or the user. The same way as in the branch, you expect the branch to be or the branches or whatever you're loading here, whatever data project repository, doesn't matter.
Yeah,
You will have it here.
And on that note, it would be awesome if you try to infer what you're looking at now, because now we're doing exactly what we're talking about. We have a session, we mount a branch, but now we need some data. We need the branch data, and we need picture connected. And here you see an example of how we're using a component to do that data fetching.
Because the component, I mean, the whole subtree of branch has async requirements or async dependencies, right?
Yeah, there's no reason to show the editor until we know the branch data and we have a connected picture.
Yeah, and then use, I guess, as far as I read, use is kind of, it's almost like it's hiding async stuff, right?
Yeah. Exactly.
Because the moment when you see this, you think, oh, I need to, like TypeScript, I'm flipping into TypeScript mode. Oh, something is a promise of whatever I'm fetching there. But I don't have that here, right? There's no, or is there? Is data a promise type? No.
Yeah. Well, yeah, that's the thing.
It's kind of like what I expect with use, right?
Yeah. So branches.fetch, that method returns a promise. But then because you use around it, you kind of dive into the promise and you get the actual data.
So this is what is cool about this new approach, is that the file tree also represents the data. We can rely on the data, but the component itself is, once you are executing each line, reading each line, you can see that the data is there or not. So it no longer needs to add a lot of conditionals to make sure the data is there. You can simply write your code and rely that it will be there. And this reflects in the component tree, but also in the component itself, how the component is executed.
Yeah, it's really interesting.
What's nice here is that you it's much more imperative.
Mm-hmm.
Async stuff is naturally imperative, right? Like it's the the easiest way to reason about async stuff is imperatively, right? When you start adding like declarative stuff and like you think about callbacks and stuff like that, it makes sense on the spot, but it scales badly. The mental model scales so badly.
Mm-hmm.
um, I like this. Like I'm
Yeah.
handling I'm handling results in this. In my mind, I know this is kind of partially declarative because it's React, but this feels more imperative in my mind.
Yeah.
I'm doing something. If this, do that. If that, do this.
Yeah.
Like it's kind of like the simplicity of the Overmind implementation from
Mm-hmm.
V1, where an action is an async contract thing. You're awaiting something.
Yeah.
If data is that, you return this. If not, you set state. If not, you throw. You don't have to care about um,
Yeah.
like about side effects. I would argue here.
Yeah. It's I haven't thought about it like that, but it's really true. Like it, if you forget about this being a component and you forget about the return statements here, it looks like an action, like you're imperatively doing
Yeah,
something. It just
exactly.
happens that when what you return is what is going to be displayed, uh,
Yeah,
which is really interesting.
I mean, arguably this could be. It's almost like this gives me vibes, slight vibes of uh, something like the a get initial state or something like
Mm-hmm.
that. Maybe that's where next is also coming from, with this kind of pieces of code that you clearly associate with a component because you are in a component model, but you want that contract very tight. Again, I'm thinking of this index file as a very tight contract
Mm-hmm.
uh, for how you handle the async nature of the loading state.
Yeah.
But this is just the loading state, right? It doesn't say anything about how you deal with uh, asynchronous flows after the loading state, right? After the loading state, you have to go inside the editor, and that's where you handle,
Yeah. Yeah.
mutations, commands, whatever you are dispatching,
Yeah. Yeah. Exactly.
whatever the user actually, yeah, exactly, like whatever the user controls is inside the component, whatever the app controls is outside wrapping.
Yeah. And it's really interesting. Like this component is super interesting because it shows so many things. And the first thing is like when I implemented this the first time when we had the primitives, this was 3 different components because I had an old mental model of how this could be achieved. And then as we like Danilo and I discussed and I learned more, I thought, wait, I can just make one component describe the complexity of asynchronously initializing a branch. Because if you look at what we need here to do this, like first we need to have the branch data because we can't connect to Pitcher without knowing the ID of the branch. So that is
Yeah,
what we're doing on line 21. It's like, okay, we just
exactly.
need the data here. Let's use the use hook and suspend it. We can't move beyond this point until we have that data. And then on the very next line, we're using that data, the data ID.
Yeah,
But in this case, we're not using suspense. In theory, we could use suspense and wait for Pitcher as well. But because we have this progress happening while the promise is resolving, we rather consume the promise as is. But the thing about suspense and promises is that to make the use hook work, the promises gets this status property. This is something React does. They have a suggestion on this where they basically populate promises with a status. And
hmm
if it's pending, it only has the status pending. If it's rejected, it has a reason property, and if it's resolved, it has a value property, so you can like synchronously access it. So what we're basically doing here is that we're using suspense for the data, and we're now just using the promise status to show the in progress message while the promise is resolving. And all of that complexity is just a few lines of code, like step by step in a component, which is insane to me that it's possible to do that.
Yeah, but it's interesting because this kind of breaks the mental model of classic React, where you expect, okay, this cannot work because this will just re-render infinitely.
Exactly.
in the model of, like that obsession in a way of like, oh, I'm just gonna drop this UI, this like like this a tree of components, and whenever you want to make a change from branch A to branch B, is just gonna go all the way to the top of the tree and just flow through the whole thing. But this works differently then, right? Right, because this only, and it's right nice, it's right quite nice because you see like the props of this component are also the dependencies of the contract. The contract does not change unless any of these change, right? There's no more need for a use effect to listen to the router change something. And
yeah, exactly.
That's interesting. We didn't realize that we didn't add any use effect here. Like it was so natural to write this code,
I think the moment
and we
when you
simply
have a use
forget.
effect, the moment when you have a use effect, doesn't this just how that work even? Like,
yeah, if you were going to use a use effect,
does use ensure that it only runs once? How does it?
Okay,
how
yeah.
can it ensure
So
that it only runs
technically,
once?
how does this actually run? So it starts with the call to fetch, branches fetch. And what we're doing there is that we are just doing a fetch. Yeah, we can look at the code. So what we're doing here is that we are just running a promise, but we cache it. So we have a record of branches where we insert the promise. But we put the promise in what we call a signal. We can talk more about signals. But basically what we're doing is that we're not creating a new promise every time we call fetch, because fetch will be called multiple times. But we cache it. So we always return the same promise. And this is related to the suggestion from React that the use hook from React won't cache the promise. It will just read these new properties on the promise to evaluate what it's going to do with it. So it's up to library authors to create the caching mechanism. And this is what use fetch and use query and use SWR does as well. They cache the promise. So we're just doing it manually so that we have control of when do we actually want to cache it and dispose of it and so on.
Right.
We could use query here if we wanted to do that instead, actually. So that's why.
Right, but this use branch is basically, is it an abstraction over data fetching plus cache? It's basically CodeSandbox API would be abstracted behind, like in.
Yes, that's a good point. Like the thing about React is like, and a package like CodeSandbox API is that CodeSandbox API is low level. It creates a promise for you, and that's what it does. You just have that promise, and you can't just take that promise and put it into React. You need a layer in between that, in this case, makes that promise reactive, so that you're able to observe changes to that promise. And in this case, also use it with suspense. So something has to do that for you. And that's what we're doing here with the signal, is that we're using CodeSandbox API to create the query, but then we put it into a signal to make it observable. And then we manually cache the promise, because CodeSandbox API doesn't cache these promises.
Right.
So that's what it does. It caches and makes the promise observable. That's what it does.
And what does the signal do? Where does the signal has its part here? Is it just the fact that the fetch returns async when when the promise is resolved?
Yeah, so we're diving like kind of deep into what signals can do, but a signal is just something that holds a value and makes that value observable. So you could create a signal with just a number or some text or whatever. It doesn't matter. In this case, we put a promise in there.
But so it has a subscribe type of API?
Under the hood, it has a subscribe type of API, but that's the thing that I hope we can also talk about, is how weird it is, right? That you can just consume that promise. There's nothing in the component that says that it, like, where does it subscribe to this promise changes? Like, that's weird, right? And it just does it. The point is that you actually don't have to think about it. So to dive into that, like these contexts, the way they expose state to the components is using signals. And any component that consumes a context automatically subscribes to any signal it accesses from any context. So that means that it automatically
has a use on that signal, right?
You don't have to do that. That's suspense.
Oh.
Just the fact that you're accessing it. You just have to start using it in a component. You don't. The point is that you're not supposed to think about it.
How does it know about it?
We can. Yeah, I'm just trying to think of if we should look at a simpler example for signals.
No, let's skip it, because I can take a black box here on the on the
So
right, let's take a step back then on the.
But if you hover the client promise, you see that it's not a normal promise; it's a promise signal.
Yeah, so it's a promise signal. Yeah.
So whenever you consume something that comes from a signal, the component will automatically understand that you accessed it, and it will reconcile if that signal changes.
Status, and these are like, they have like some sort of getters, or there's some proxy or stuff like that.
Something.
Okay, let's not get into it.
Chris doesn't want to tell the secrets.
The secret sauce. Okay. Right.
We can talk more about it when we jump into the branch context, because it has like the mutations and stuff.
Yeah, I wanted just to have here one last look over this. I wonder if this, like the fetch itself, does it need to come wrapped and exposed into a hook, or can it be defined how should I put it? Can it be defined like I have this kind of annoyance with the fact that there's no, and I don't think any framework actually has this, other than maybe like a very tight GraphQL implementation. There's no distinction between state management and data fetching, as in, let me just define data fetching as these are my needs, this is the data, this is the contract that has to go to various endpoints, mutations, queries, maybe subscriptions. I don't know. Let's not go there. And I want this to be as external to the architecture of the app as possible.
Mm-hmm.
But that's just me. I don't know if that's something you ever considered here.
No, I think it makes sense, and this is like
Because why I'm asking is because this feels very uh, not coupled, but feels very specific to the context
yeah,
and provider pattern that is implemented here. And it's almost like you're bringing then all the logic behind, okay, which endpoints I go to and how do I serialize or deserialize that data,
yeah,
where are the queries, which are the data types. It's kind of like brought in into the state management part, which is,
yeah,
I think that was kind of the doom of Redux and the first generation of state management tools, that all freaking data was flowing through these very unnecessary complex flows of dispatching actions. And yeah,
yeah,
you know.
exactly. And it is a really good point, and the thing is like it's also you're trading, like you can create these abstractions that makes it more straightforward, and as you say, you kind of push it outside of the state management, but to some degree it's also tied to the state management in terms of when do you want to like bust the cache and stuff like that.
Right.
So it's more I'm not saying that this is how it should be done. This was more like this is what needs to happen under the hood. Like there needs to be a caching mechanism there for suspense to work, um, and so on. But you could abstract this into whatever you wanted, really. What's interesting about this though is that in the sense of these contexts is that unlike a traditional React context, they can be as big as you want. It doesn't matter how big that context is, how much state it manages, because it's only the state that's actually being accessed by a component that makes it reconcile again. So that brings like a different challenge, is that, oh great, I'm not constrained by the how much state I put into a context, but then it's more like how do I structure the state of the context? Like here we separate it into
Yeah.
different files, and how do you like do that? But back to the data fetching, like there's also a valid pattern here, I think, where you just do the data fetching using use query, for example, and then you use the contexts and you just give the data. You like if you go back to the to take an example, if you go back to the where we
The
load up the
session.
branch,
Yeah.
back to the component where I think it's the branch index file, the actual UI component.
Here.
Yeah, here. So here we are like using branches.fetch, and we're using the usehook, but we could have used use query here and fetch the data using use query. And then,
Right.
as you see below,
Then
we're just passing the data into the branch context. So that's also a way to think about it.
Okay.
Yeah. Exactly.
So you're fetching here, and then you can rely on the cache that the library provides, like let's say use query.
Yeah.
Or you put it here and you do the caching, and you then provide it, and then you use it whenever you need it. You use the context, the branch context, right, to consume the data.
Mm-hmm. So then the data becomes so you wouldn't. So the point is that thinking about use query as an example here, you would just use query to fetch the data in the component, but you use the context to expose that data to any nested component. So you wouldn't use query in the nested components. There you would just consume the context.
But the pattern that people are used to is to use query in multiple places, because you rely on the caching of use query.
But there's another beautiful thing about this, and I haven't talked to you about this yet, Danilo. But that is when you provide the data to the context, you can put that data into a signal so that you make it observable. And that means that you can choose how granular that's supposed to be. So as an example of that, it's like we have this big branch data object, and we don't want every component to reconcile whenever something changes in the branch data. But that's what happens with use query, right? If you change something there, you change the whole data. But here, when we provide the data to a context, we can choose to, okay, let's make the title a signal. We'll make the is a GitHub app installed a signal. And then you can observe those in isolation so that only the state you actually access causes reconciliation. And you get optimistic updates because you can just change them without, you're not changing the cache data. You're just changing these signals in the context. So you get optimistic changes, which is also really nice. So you kind of, as you said, you're separating the data fetching from the state management, but the data has to go into the state management at some point.
Yeah, that's the model that you need to get adjusted to, I think, here.
Mm-hmm.
But so it goes into state management because state management is basically data provided, is not, when you think something goes into state management, you think, oh my God, this is going to re-render then tons of things. But having a signal here is going to protect that, against that.
Yeah, exactly. So in this example, we put all the branch data into a single signal, which means that whenever we want to update the branch data, the signal updates, and any component using the branch data signal will reconcile. But we could change this implementation. We could say, so I can take an example here. Oh, did I break out? Yeah. Do we have title on a branch? I can't remember. So I could say signal branch data branch dot. Oh, sorry.
No, we don't have.
Oh, sorry. We already did this.
So branch
sorry.
is just a string. Yeah.
Yeah. Sorry. Yeah. So we already broke this up. It's just that we don't have any other signals than the branch. But
yeah.
But so you could imagine we had like GitHub app installed
to make it clearer.
So if something,
it's just data that feels confusing here because this is the object that you're exposing.
Exactly. So
whereas branch is exposing the signal, right?
Yeah. Because ID, owner, and repo never changes, but branch can change. Yeah.
Yeah.
So yeah,
you need
what
at computed. Yeah.
So the the effect of this is that, okay, now we put like the initial branch name into that signal, and now we're free to just change that signal whenever we want. So that means in terms of maybe we would add like a rename method here, and as part of that rename branch method, we would just go and change the signal, the branch name of the signal. And then if something failed, we could just as easily revert it back to the old branch name, and so on.
Yeah. Nice. Sounds good. Do you want to continue diving deeper into this, or do you want to kind of go towards a more like a conclusion?
Go and look at the Git.
Right. So Git, first of all, is part of, right. So the only difference, just to clarify, the only difference between the branch context and the session context was just split into like the picture and the branches. how do you call these, like state
Yeah, what do you call
things?
them? Yeah, that it's the like the
The
latest iteration
right.
we did is that what should we like name when you do choose to like split it up and compose it back together. Like you want to expose everything through the same context, but you want to be able to
Yeah.
split it up into multiple files. And what do you call these things? And Danilo had a suggestion that we should just think about it as the hooks pattern, because it literally is a hook you're consuming when you're consuming the context. And just like you compose hooks, you do the same here. You're just you're just composing a context
Yeah.
hook. So I think that was a nice way to do it, but it's convention, naming convention. It's not like part of the API or
Yeah.
anything. Yeah.
And the another reason to use is that because we imply that we can use other hooks inside this function. For example, we could name use branches to create branches context or something, but then you don't know that you could use hooks inside it. So kind of imply that it's a React thing,
Yeah, so you see
but
we're
it
Right.
could
using
be
the
anything
global
else.
Yeah,
context.
actually one of the things that I was wondering about, like why would this need to be on the hook convention?
Yeah, so one thing that we haven't talked about
But yeah,
here,
I see.
which is not like apparent, is that these contexts, they aren't part of the reconciliation loop. So when we define a context here, the function here, it only runs once. So if you go back to, yeah, for example, here we're defining the branches. Like that will only happen once. So it's kind of like our existing implementation. It looks very much like our existing implementation of creating contexts, like these feature
Yeah.
contexts. But those are tied to the reconciliation loop, and they run again and again and uses the primitives, the hook primitives from React. This is the same thing, but it only runs once, and it uses reactive primitives instead of React's.
That's because of the special context implementation here, right?
Yes, exactly.
Okay.
So that kind of frees you from the reconciliation loop. You don't have to like use effects and dependency arrays and all of the problems that comes with a React context, especially the problem that whatever state changes within a context, any consuming component will reconcile. Well, here it's based on what signal you actually access from a component.
Right.
But
so you rather risk not reacting to a change, but that's more visible and easier to correct than the fact that you're reacting to all the changes all the times.
Yeah.
If you just start adding use callbacks and use effects and
yeah, and that's a really fair point, right? It's not like magically perfect to use observability. And I think
right, because you can miss things, right? You can create disconnected slices of the app that don't react to these changes unless you explicitly say, hey, I want you to react to this.
Yes, and that's a thing I really like about like the latest iteration here is that, so for example with MobX, first of all you have to explicitly tell the component that it's observing. Like you have this observer higher order component, and you can forget to do that, but that's not like a huge deal, but that's a threshold. But then if you were to pass a value from MobX as a prop to a child component, which is an object, you also have to make sure that you put a observer higher order component around the child in case you access something in that object. Because in MobX you have mutation, so the object doesn't change when you change something within the object. So the child wouldn't like that's a harder thing to think of and identify. But in this concept, all the signals are immutable. So when you change a signal, it's like you have to change the whole value. And the only place that this observability happens is when you use a context and you use values from that context in the component. And
Mhm.
the values you get from the signal are just normal, like immutable values. So if you pass these to child components, it works exactly the same way. So I don't see you getting into the issue where you like forget to add an observer, because you don't have to. You get an issue with a child component because you forgot to add an observer to the child component. That won't happen
Mhm.
because it's just normal data or normal props.
Yeah, it flows through to the, like here, right? Like, not like here, like the, where did I see that? Oh no, in the component, in the branch. Yeah, like here.
Yeah, exactly. Yeah, so props are props. There's no change to that. The only
Yeah.
change is that whatever you consume from like the use context, whatever context you're consuming, that will cause this component to reconcile if the consumed signal updates. But practically, you don't
But
think
this
about it.
is
You
not,
just use it.
yeah, and but this is not necessarily a signal, right?
Doesn't have to
Uh,
be. No, doesn't have to
yeah,
be.
because like in that example, where is it here? Yeah, these are also passed in through the context, and they can be accessed as regular data, right?
Mm-hmm. Exactly.
Right. Cool.
Um, there was something.
The Git.
Yeah, was that what? Yeah, we were looking at that because it has an interesting thing, a couple of interesting things in it.
Yeah, I wanted to ask like where does this, how does this then mix with the idea of explicit states in
Oh yeah, so
classic state management, let's call it.
yeah, so at least one thing I learned through us like really going hard on like explicit states. The thing about React states that we're using now is that it has the good stuff, which is like the explicit states, but then it also has this bad stuff where you first have to go into the reducer and change the state, and then you have to go out of the reducer again to figure out what happens when you change that state.
Mhm.
So I think in terms of like state machines and explicit states, it's really what you see here, the suggested commit message. That's like the
Yeah,
core power of it. It's just having a
just
union
the
of
data.
different statuses.
Yeah,
Yeah. And then
yeah,
don't like tie that into like this reactive effects behavior. It's just a way to express a state that can be in multiple states, kind of thing.
right. But then how is this set? Oh, it's just assigned to.
Yeah. So what you're seeing, here is a couple of interesting things. One thing is like
Okay,
suggested
this is
commit
coming from
message,
the, yeah,
but then you
but
also
yeah,
have suggesting commit message. I think, did we call it that? I can't remember.
yeah, this one.
Yeah. So I'm not sure why we suggested commit message can be undefined. Yeah, I think we forgot to change it, Danilo, because we didn't have stale. Oh, sorry. No, it's correct because you might not have anything yet. Like you might not
Yeah,
have any Git status that should produce a suggested commit message yet. It's like the initial state is nothing. You
initial
don't have
state.
any suggestion. Um, anyways, but that's really just a normal state value. It's just expressed as a stale and fresh state. But then you have the suggesting commit message. So
Mm-hmm.
if you go to the method that's called, if you go
Suggest
way,
commit.
yeah, this is, we can look at the effects after that. But if you go down to
Ah,
a
okay.
more normal thing, which is like at the way at the bottom, So if you think about this imperatively, you just want to click the button and get a new suggested commit message. That would be the method down there, like suggest commit message.
And this is exposed on the context, right?
Yes, exactly. So here it takes the files you want a suggestion on. And what's interesting about it is that it just assigns the promise of calling suggest commit. So we are assigning the mutation promise to a signal.
Mm-hmm.
And what's
And
interesting,
and then return it again. Like we
and
can
then return it.
assume this status, this signal.
Yeah.
And what's interesting about that is if you go to the sidebar component, I think. Oh, sorry, Git panel. Sorry,
Git
of
panel.
course.
Oh, and here's the suspense again. We have another boundary for the suspense.
So here you can see, because this is also a problem, right? We talked about data fetching, but you also have mutations that kind of goes in the other direction. And there's a different way to consume mutations. Like fetching data makes sense with suspense. And you want to consume the data directly in the component because you want to evaluate what do you want to render kind of thing. And pass that data along to nested components. But a mutation is more about like, what's the state of the mutation? So what we're doing here is that we just have a signal that represents suggesting a commit message. And whenever we suggest a commit message, we assign the promise of suggesting a commit message to that signal. So that means that you can observe that. So in the code here, you can see that we are, the opacity, it changes when we are suggesting a commit message and that status is pending. Then we change the opacity.
Mm-hmm.
So whenever you run a mutation, you don't just create a promise that can't be used in React. You actually assign the promise to a signal that can be observed in React. And then any component consuming the branch context can look and see, are we currently suggesting a commit message now?
Yeah. Yeah, and so then you basically can consume anything from here. You can consume the Git side of the branch context, which is defined here.
Mm-hmm.
And anything you put here then becomes consumable below the provider of the branch context.
Yeah. Exactly.
Yeah,
That's also a thing is that we're also seeing in our current code is that we have all these features, and how do you find them? How do you explore them? And that's interesting about contexts is that you will have way less contexts than you will have like features. So what it means is that you can, when you use the branch context, you can explore a lot of different things. Like what can I do within a branch? And then you can explore what can I do within a session. Like literally you can dot into the object and you can look at it and explore it and figure out what you can do. As opposed to, okay, I'm in a component now. I have like 40 hooks in this folder. What do they do? Can I use them here?
Yeah.
And so
how do they how do I know that they react to the data changes?
Mm-hmm.
Because I only see them as hooks with a return type, right? It could be like yeah, I find it maybe it's a bit still needs a bit of time to sink in. I feel this is simple when you look at this. Is it's what you want when you create a component. You don't want to deal with complicated, like, oh, let me do a use effect to listen to props changing and run a mutation, and when the mutation returns if no data, return null if, like, it's almost like all that is extracted away from this, right?
Yeah. Yeah, exactly. And this is like the really tricky part. It's like you have this paradigm in React, and even though we have our challenges now with performance and like the dependency arrays and reconciliation loop, and like what happened, what state change there, what happens then, it's still React's paradigm that we know. And then if you want to do like performance state management, you have to change the paradigm. And then the question is like, do you introduce a very different paradigm? So for example, with MobX, we could like use classes and MobX and the API from MobX and stuff like that. Or maybe we would use, even with Redux, it's a different paradigm because you use thunks, for example. Like it's different than what React
Yeah,
is. While this approach is also a different paradigm, but it tries to cling to React as hard as possible. So you think about it as just creating a hook for a context, but instead of using use state and use effect, you use signal and effect. That's kind of like the mental model that it's currently trying to do, at least.
right, like signal holds the state and effect
Yeah,
uh, wraps the changes to
yeah,
that state. Can I call it like this? That's how I see these.
yeah, exactly. So effect is just a use effect, but instead of having a dependency array to figure out when things change, you
Yeah,
just use
which
things. You just define
yeah,
it, and
which is
whatever
how
you access.
yeah, it's almost like this is how the framework should actually work.
Yeah. So I think that's like the best way to wrap this up, is that uh, impact is just a reactive context where you use a signal instead of use state and effect instead of use effect. That's the
Hmm.
only difference at its core.
Yeah, yeah. The key is here to make to abstract away the right things
Mm.
so that I'm not saying that uh, like impact as at its core is well abstracted because we talked about these things. I
Mm.
wonder if there's a secondary abstraction here, which is
Yeah.
a developer experience abstraction that
Yeah.
we need to have, right? Which is
Yeah.
your custom project abstraction. We say, oh, I know that I'm maintaining more code that I'm creating. So then let me see which is the right abstraction to ensure that data makes sense, scales well as I bring more and more stuff into providers.
Yeah. Yeah.
Or you say, oh, actually I just create a bunch of stuff, like it's a very rapid development project, so I need a way to just initialize, like I need some very standard functions, like all
Yeah.
the entities need a get, need a read, create, read, update, delete. I don't care about individually defining those every time with three mutations and one query.
Yeah. Yeah, and it's such a good point. And Danilo and I had this insight. I don't remember if it was on the stream, Danilo, but we talked about how libraries should always have two abstractions. They should have a low level abstraction with the primitives,
Yes.
and then they should have an opinionated higher abstraction.
Yeah.
And then you can choose to use the low level things if you want a different opinion.
Yeah.
So as
And
an
that's
example, yeah.
that's in my mind, that's the big thing that lacks in React, right? You
Mhm.
have to know the low level thing. You have to wrap your head around suspense, effects, rendering cycles, which are implementation details of the framework. What you want to build is data flowing through some components,
Mhm.
reactive is possible to
Yeah.
events connecting your endpoints and the rendering fast. That's the purpose of the framework. The fact that you have to go into the internals. I have this kind of thing that I always say that React feels like you're working with the internals. It's almost like you're in surgery and all the organs
It's a
of
good point.
React are on the table, right? And you have to say, oh, I have to pick this and I have to pick that and I have to, make
Yeah.
sure that I do the connection. It doesn't come with it included
Yeah.
somehow.
Yeah. It's a really good point. And yeah, like, so in this example, like an abstraction, like if you took a really high abstraction, you could go to a very traditional approach. You could just call it a store, and you would
Mhm.
like just initialize it, or the store could get like props, so you would provide it and then you would get the props here, and
Yeah,
you could like just initialize it with an object declaratively, as opposed to implementing
yeah,
a function scope. It reduces
yeah.
some flexibility, but as you say, like it's more approachable, it has some
it,
opinions,
it's
and
it's
yeah.
yeah, it's a trade-off thing that you
Hmm.
want. Sometimes you want, especially if you think, okay, we're a small team and we can probably work out we can work with the abstraction inside, but the moment when you want to scale a project to like 20 people
Yeah.
and you have different levels of engineering from junior to senior, you want the architecture needs to be as simple as possible. If it's in your way,
Hmm.
it's just it creates havoc. Like it wreaks havoc in the long term.
Yeah.
If people have to learn the architecture, they don't have to they just have to understand it. They don't have to learn it. That's, I guess, it's a
Yeah.
weird
Yeah, I think
thing.
it's a really good point. It's also the best form of best practice and guidelines is if you have it's in the API. Kind of, you don't have
Yeah,
to write about how to write code. As long as you use this API, you're doing it right. Kind of thing.
yeah,
Yeah.
yeah. But no, I like this idea of like the two levels of abstraction. I think that it's also how we build Sandpack and how I think
Yeah.
it's just the right model for any library. Like
Yeah.
give me the the abstraction, the most the higher level abstraction that you can give me, that function that gets a parameter and returns something,
Hmm.
right? But then also give
Yeah.
me all the pieces that I can build my own function if I have a specific scenario in mind.
When we were talking about this API thing, we I used the exactly same example, which is Sandpack. I think you did a great job there, where you can simply import a component Sandpack and it works. You don't need to think much about the layout, the how to consume any other thing. But if you want to create custom stuff, you have different levels of customization,
Yeah,
and you could end up in the Senpai client, which is the the most basic interface. Like you can do whatever you want with the Senpai client, and yeah, I kind of like the way we were thinking when we built Senpai and
Mm,
something to
yeah,
learn.
definitely.
yeah. But it's in for UI component, it becomes even more natural where you can
Hmm.
either customize something by you either offer like this very generic API with an opinionated set of props, and then you control everything through those props, or you pass in or you expose mini components or all the possible components, but then the component composition is up to the implementer to figure out.
Yeah.
Yeah,
State
That.
management may be a bit more, it's a bit more delicate because I guess it's a step more complicated than like components are very easy to grasp as a concept. I would argue state management is a bit more abstract.
Yeah, but I think I think it's that we just been using the wrong perspective. Like it's because state management is very complex, so we try to like abstract first and then try to find like a simpler way to define things instead of finding a lower level primitive that can produce different abstractions. Because I've never seen that before. I kind of I guess you could argue MobX is quite low level actually. You can choose to use it with classes. You can just create observables globally in your app, and then they created MobX State Tree, which would be an opinionated abstraction over MobX. So I guess, maybe to some extent it has been done, but a lot of them it's just a very high abstraction and you can't change out the patterns to your liking. But talking about this now, it would be really fun to like take this code, because that's what we've done now. We kind of go down into the specific, like we have such a hard time expressing this and this and this and this. And now we like found primitives that lets us express that in a way that's easily consumable in a component, and doesn't split things up and so on. It will be fun to kind of take these and try to, okay, what would a high level abstraction of this code look like? And then see how, because the components now are super, super simple. How would a higher abstraction make these things look even simpler? I wonder. Yeah, because you have these quirks of like when you define a signal, we use a getter to return the value. It's becoming a bit of a more common pattern, like Svelte is doing this now with their new runes system. But still, it's like you don't have to do it. Like there is a higher abstraction that kind of hides that away and lets you just focus on the state. I'm inspired. Cool. But yeah, we're over time. But this was great, Alex. Thanks for taking just jumping into it without knowing anything.
Sure.
And it's such a good test for something, because one thing is technically trying to fix the challenges we have, but we're also trying to fix other developers jumping into the code and be able to reason about the code. Because that's also been a challenge for us.
And it's quite interesting because the challenges are so different. When even though we strive, we're not yet there, but we strive to build one product, but the challenges are so different. When you need to build like one thing is building editor functionality, one thing is building like layout management, one thing is building model messages that or model windows that are mutating data persisted in local storage or in the backend. One thing is managing rendering data like hundreds of branches, repositories, sandboxes, whatever. It's different.
Yeah, there's a lot of stuff to dive into. That's for sure.
Okay, cool.
But yeah, awesome. I'll just end it there. And I got really inspired by this. I'm gonna try something, and maybe we together. I think there's more to explore regardless, but it would be fun together to look at like what would like a higher abstraction look like. Like take this inspiration from Sandpack and kind of state that, okay, we found the lower level primitives, but what would like the higher abstraction version of Sandpack be in this this context? Ooh, I said context. Nice. Thanks. And I guess we'll talk more later.
Yep. Bye.
Thank you.
Bye-bye.
Bye.